Alright, here is my second video on formulae calculations, to which I'm going to look at three today. I'm going to look at relative formula mass, which is by far the most important calculation in chemistry, and it's the basis of all others. I'm going to then use that to be able to identify an element from its formula mass and its formula, and then we're going to look at what we call the percentage composition, which is the percentage of each element present in the formula. So, without further ado, let's get started. So, let's start with the relative formula mass of sodium hydroxide. So basically, with the relative formula mass, you add up the relative atomic mass of each element present. So sodium, for the periodic table, is 23, and looking at oxygen, that will be 16, and looking at hydrogen, that'll be 1. So we're adding together 23 plus 16 plus 1, and that comes out as 40. Fairly straightforward. Now, one slightly harder, looking at magnesium sulfate, but the principle exactly the same. So magnesium is 24. Sulfur's relative atomic mass is 32. Now, when we look at oxygen now, if we look at that formula, there are 4 oxygens. So we've got to have 4 lots of 16. And that will come out as 24 plus 32, and 4 16s are 64. All of that adds up to 120. Now, the only difficult part is when we have brackets. And if we deal with brackets just like we do in mathematics, it doesn't become a problem. So for zinc nitrate, we've got 1 zinc and its relative atomic mass is 65. Now, if we look at a bracket, that 2 outside the bracket doubles everything inside. So that means we've got 2 nitrogens, and the relative atomic mass of nitrogen is 14. That's the oxygens that we have to be really careful with. Now, the mistake people make is they add 2 and 3. This is not an addition, it's a multiply. So 2 times 3 is 6. So 6 times 16. Once you realise that, it becomes fairly straightforward. So 65 plus 2 14s are 28, plus 6 16s are 96. And when we add that together, we get 189. Now, using these simple rules, you can do any relative formula mass. I hope that's straightforward. Now, using that idea, what we're going to be doing this time is identifying an element from its formula and relative formula mass. So, for instance, here I've made up this unknown compound XF2. It's got a relative formula mass of 78. So what that means is that the relative formula mass of XF2 equals the relative atomic mass of X plus twice the relative atomic mass of fluorine, F. So, the relative atomic mass of X then will equal the relative formula mass XF2 minus twice the relative atomic mass of fluorine. So we're given the relative formula mass of XF2, which is 78. If we look up in the periodic table, the relative atomic mass of fluorine is 19, so 2 times 19. So that becomes 78 minus 38, which will equal 40. Now, if you look up in the periodic table, you find there are two elements with a relative atomic mass of 40. There's calcium and there's argon. Now, this can only be calcium because argon is a noble gas and doesn't form a compound with the formula XF2. So, fairly straightforward there. That's by far the easiest of the calculations. Now, the third type is this, percentage composition. Now, the percentage composition means this is the percentage of every element present in a compound. So, I'm going to use carbon dioxide as an example. So, always for these calculations, the first step is to work out the relative formula mass. That's why I said the relative formula mass is by far the most important calculation that you will do. So, if we look at this, there's one carbon which has a relative atomic mass of 12. If we look at the formula, there are two oxygens with a relative atomic mass of 16. So 2 16s are 32 and 12 is 44. Now, the percentage carbon then will be the mass of carbon present divided by the relative formula mass times 100. And when you work that out, that will come out as 27.3%. The percentage oxygen will be 32 divided by 44 times 100. And when you work that out, that will come out as 72.7%. Now you may say, oh, we could work out the oxygen quicker than that, just by subtracting 27.3 away from 100. Yes, and I'd use that as my check always. So, whichever is best for you. Now, slightly harder. We've got 3 elements here this time, but the method is exactly the same. So, let's work out the relative formula mass of magnesium sulfate. The magnesium, 24. Sulfur, 32. And we've got 4 oxygens, 4 times 16. So, 24, plus 32 plus 64 equals 120. So the percentage magnesium will equal 24 divided by 120 times 100. And when you work that out, that comes out as 20%. The percentage sulfur, as we can see, the mass of sulfur present in that formula is 32 divided by 120 times 100. When you work that out, that comes out as 26.7%. And finally then, the percentage oxygen is 64 divided by 120 times 100. And when you work that out, is 53.3%. Now, just an activity in terms of percentages, I would suggest no real issue to you. So, follow this method and you'll be able to work out the percentage composition of any compound.